Today we're going to finish up chapter 12 sections. We're not going to do 12.4. It is not beneficial for Cal 2. And Cal 2 is why we're doing this particular chapter. And we're going now into the geometric. The previous one was arithmetic, which means that constant was added. The difference, the little d, was what we were calculating for in order to find the order of what we were doing. And so on this one, we're geometric. That means exponential in some form. Exponential is what rules the world, especially with e to any exponent as well as pi to any exponent. All of those are exponential in concept, meaning their growth is doubling or tripling or halving or whatever, because we age things using the geometric series. Okay, so the first thing I did was copy some stuff out of the book because I think it's crucial you know that I do follow the book. I know sometimes I forget to do the homework so that I know what the book wants, but I'm getting better at that. Thank you for all of that attention. So the definition is really complex because it has a constant, lowercase a, b, c, etc. The lower cases are numbers, so that you'll know. And in this case, a geometric sequence is defined recursively. Okay, recursively means that it has a pattern of growth that is exponential, where we have the a's of 1 equal to a. And then the a's of n divided by one more of them should give us an r. Okay, the r is what we'll be looking at because the r is the impact that happens on this series and sequence, multiplier as it were. Okay, we can't have 0 for a, but it is under n minus 1, and r cannot be 0. And therefore we call the r the common ratio, and that is the same as a multiplier. Okay, like a multiplier. A common ratio. So our theorem comes off of this guy. Notice that we have a of n equal to a of j, r of n minus 1, where the common ratio is growing or decreasing, whatever the nature may be. Again, we're talking about natural numbers. For n. N meaning what we start with. That means we start with the set of 1, 2, ... to infinity. All of these natural numbers are the only ones we play with as an exponential. So here we have infinite geometric sums, which is the total of what we have there, and our a as an amplitude. Okay, so this part here is, again, changing everything to our summation factor of the a times the first number in the series times our common ratio to k minus 1. And I refer to it as n minus 1, but k being whatever start we do. In other words, in a geometric series, we can start in the middle. We can start at number 3, but we still have to consider everything prior to 3 in order to get the a, that multiplier. All right, here we go. So we're going to start with this guy right here. And it says, show that the given sequence is geometric. Well, if we look at it, we see it. But they're saying, prove it. Prove it. And so to prove it, we take the initial order and do one less of it to see if it's a non-zero. So here we go. 8 to the n divided by 8 to the n, n minus 1, one less. Sorry about that. No, I got it right. Sorry. All right. So this is a complex fraction. So we're going to do a keep, change, flip. Or in the sense, we're going to subtract because they're the like bases. So we're going to say 8 to the n minus the exponent of the bottom one. When we do that, we're going to do distributive property. And we get 8 to the 1. Well, what is 8 to the 1? 8. So 8 is a solution, and it proves it is non-zero. Okay, what is the value of the common ratio? And in this case, we don't have one. We have an R, but we don't have one. The book put it as an 8 because it's 1 times whatever we have, and it put it as an 8. I didn't agree. I thought it was a 1, but that's what they did. So now all we're doing is substituting n. All right, so in the first term, so if I'm doing that C, the first term, I'm going to have 8 to the 1, which is 8. And then for D, I would have 8 to the 2, which is 64. For 3, I would have 8 to the 3, which is, and I'm not that good, hold that thought. Okay. Yes, 512. And then we would have our D, which I did not type, which is the 4th term because they wanted 4. And this is big, showing that it's a geometric 4096. Now, some of the actions in this book are not workable, so please don't make this any harder than needs to be. You have like 5 of these varied series that you prove first that it is what it is, and second, that you do the first 4 in the series. Now, there is a way of doing these sequences on the calculator, but it is constantly labor intensive to go to the mode, and so I'm just going to do them by hand, if that's okay with you all. All right, here we have a base of 2 n to the 1/5 divided by 5, and this is our series, and so we're going to first prove it. So I'm going to have 2 to the n over 5 over 2 to the n minus 1 over 5. So they're like bases, so I'm going to subtract the bottom one from the top one by the rules of dividing like bases. When I do that, I'm going to have 2 to the n over 5, and it's all going to be over 5, minus n plus 1. When I simplify, I'm going to get 2 to the 1/5. All right. So that is proof that it is non-zero. It's an ugly decimal, but we're not going to do the decimals at all. You're going to write what you see. So the common ratio is 2 to the 1/5. The first term then is going to be 2 to the 1/5. The second term is going to be 2 to the 2/5. The third term is going to be 2 to the 3/5. And the fourth term is 2 to the 5ths, which again, simplifies whatever work content you're applying the series and sequence. Is everybody comfortable with that? Everyone comfortable with that? All right. Well, now they're asking us to put it together. And we have the first term, which we know that A1 is A in the rule. And our rule is A to the N equals A, and then we have R. What is it? R to the N minus 1. That's the structure of the geometric sequence that we wrote up above. All right. So in this case, they want to find the fifth term. So that's what you enter first. But what I do always is figure out what the argument is. So I'm going to do the generic A to the N is equal to my -3 times, and you're going to have to put a times in between so that or parentheses, but times is much easier to input. And we're going to put our scale, right, our 5 to the N minus 1. And they want the fourth one. Now, understand that we start with 1. Okay? We start with 1. And so our numbers are 0 outcomes. 1, 2, 3, 4, all the way till however many we want. So if we're wanting R is 5, then we put in 5 into that sequence. And we would stick that in our calculator. And it's going to be negative, folks. It's going to be negative. -3, 5 to the 4th. I got it. Just making sure I entered right. All right, so this is our first entry. Our rule, this is our second entry. This is the rule. This is the fifth term. Questions on that? All right, so you're going to have a lot of these as well, like maybe 4. And nothing hard because they want the fifth term and the nth term, which means the rule for that series, geometric series. So we know that, I'm sorry? Is the rule. It's this guy up here. That's a good question. Very good question. And it's this one. The sub n is the number that we're looking for. I just want to make sure you know. Everybody good? All right. That's a good question. All right. So we know A's of 1 is A in our formula of A to the N equals A R to the N minus 1. All right. So in this case, we're given, I'm going to do our formula first. And I know that's the second entry in what you're working with. We have a 9 times a -2 to the N minus 1. And we want the fifth term. Now you're saying, well, Emma, why are you doing every step? Well, somebody's not here today, and we want to make sure we don't lose anybody on anything. This is going to be positive because if it's an even exponent, it's a positive product. Okay, so just so you know. But we got a calculator, and I'm not doing anything by hand. 144, and it's a positive. This is the first entry, and this is the second entry. Again, because that's the way they wrote it, and that's the way they want it. I would have just worked the whole thing, and I would have given you this as an answer, and forget that. And then you would have gone, you didn't tell us. Yeah. Is everybody comfortable? All right. All right. Now, this guy has the same conditions, and all it is giving you the different looks of a geometric amount. So we know that we have a equals the square root of 3. So our a is the square root of 3 times, and our r is the square root of 3 raised to the n minus 1. So that it'll be oscillating as to how many square roots we use. All right, and then they want the 5th term and the nth term. This is my nth term. So now we're going to do a sub 5. Because it's even, we're going to get a value on this one. Got a little carried away there. Sorry. Times the square root of 3 to the 4. So I'm not going to enter the square root of 3 because it's a multiplier. I'm only going to do the second one because you'll get a decimal. So I'm going to do a second x squared to put 3, get out of it, and then I'm going to go up caret 4 and get 9. And the number goes in front of a radical or a variable or a pi. Any of the irrational values always follow after the concrete multiplier. Is everybody comfortable with that? So this is our first entry. All right. Okay. Now this one's tricky. Not tricky to upset you, tricky in concept. Because it starts with a sub 2. So already we know it's n minus 2, right? Because that's our starting point rather than the 1. Okay, so our first step is to know the rule that r squared is equal to, a's of n. Sorry about that, I wrote it. A's of n is equal to a's of 1 r squared, because we're talking about the second one. So that we're going to have a's of n divided by a's of 1 equals to r squared. Because we want r. Which is our base value. And here we go. So we're going to put in the 1445, which is the n value we have, and 5. When we do the math, I get 289. Now we need the square root to know what r is. And they're supposed to come out correct, not impossibilities. Okay? So if you get a decimal, then we've done some bad math. Okay? Is everybody clear on that? So we got R. And we have ace of 1. So we're going to have it as n of 2. And there you have it. We had to put the 2 because we started with the second term. Is everybody good? Okay. The convergence, I didn't give you any on it. Convergence is what we do in calculus. Does it converge? And this is the theorem for that. A's of 1 divided by 1 minus r. And I didn't like their problem, so I didn't give you any. But you'll see this in calculus 2. Does it converge? That's always a question. Is it approaching something doable, not doable? Okay, now we're going to talk about, they put this in this section. It's not really cool or anything, but it's something that will help you in your life skills. And we're talking about compounding. The world is, Einstein said that is the most powerful tool we have, is the compounding interest on growth. He made a comment about it. And first off, we have to find out what N is. N is the number of periods in the year interest is accrued. All right, that's why you never pay off your credit card. Okay, because they do it by the number of months or days. Yes. Yes. And your credit cards are 21. At lowest. Okay, I pay off my bill and I still get charged 21% every, if I forget to send it in on time or whatever. They charge me extra interest. So it is the plague for debt. For interest, you want it. For earning money, making your money work. To make your money work means that you should have savings. A rule of thumb is 7 months of your income should be in your savings account at all times, because your jobs are not permanent. Ever anymore. They close overnight. Don Carlos closed. I went to that all the time. Yes, it's my favorite fajita place. Yeah, that's my second. But my first, because it's right there. It's beautiful. It's always been hopping, so something happened. I don't know if the owner died or something. I don't know. Or the rent went too high. You can price yourself out of the market, but, Okay, anyway. So if it's annual, which is kind of silly, it's one time. N is 1. If semi-annual, it's 2, twice a year. N is 2. Quarterly is the most used in our finances, and it is 4. Quarter is 4 quarters in a dollar. Monthly is another one. This is for, but CDs and stuff, they're 4. Monthly is usually when you have, when you're in Trump. You can earn, it's 12, N is 12, so you're making big bucks. Yeah, and we don't do daily in this course, but daily is 365. And some of them use 360, which is a business calendar year. Some of them use 360, depending what what you're earning. So what do we need? Well, we need a formula for compounding. And the accrued amount, the accrued amount earned on a savings is principal plus 1 plus the rate as a decimal divided by the number of interest payments per year raised to the n times t, the number of payments times time. And time is always in terms of year. You can do it for half a year, 3/4 of a year, but it's in terms of a year. So let's look at what we have. 5,000 is invested. Okay. I always encourage my business people when they do their income tax, because they get it all back. They're not earning big bucks yet. I tell them, take whatever you get and invest it. Spend a little bit, but invest a portion of that income and let it grow. But that's another story. Okay, my rate is 4%. Well, we have to convert it to a decimal. It's 400ths. 400ths. My N is semi-annual, so it's 2. So my N is 2. And my time is 5 years. Okay, so when I have this, I can then insert everything in my formula. And you pay for your calculator to work. That's what you do. So we're going to do this in it. Okay, I'm going to enter the 5,000. Open parentheses, the 1 plus the 0.04 divided by 2, close parenthesis, up caret, and I'm going to put in 10. Okay. Our future value, because that's what an A is future value, and money is in 2 decimal places, $6,094.97. 2 decimals. All right. So we're given this one here, and I gave this one as well in the homework. Find the principal needed. Well, most of us want to figure out what I need as a down payment for an expensive vehicle, a home, or whatever you're putting a down payment on. So you want to know how much you need how long will you need to acquire it by savings and at its present value. So here, to get $800. Okay, the rule of thumb for apartments that are worth security is 2 months rent. So a month's rent runs from $1,500 to $2,500, depending on how many rooms you have. So that would be a good guess about what you need. How much does it take to turn on utilities? What do you think? Yeah, I haven't done it forever either. I think it's 100 deposit for the water and 100 for the electricity. Yeah, mine's longer than that. So you would need about $500 moving in cost is what you would have. So understand that, because you want to have a nice place if you're a professional. So the amount is A. Our T is 4 years. Our I is 10%, which is great. And compounded monthly, our N is 12. Okay. A lot to consider because you guys are going to be doing stuff. So I'm going to write my formula. And I'm going to put in what I know. I have 800. I don't have P, but I have everything else. And this is for 4. All right. So what I'm going to do is undo multiplication by division. And this is what I'm going to do. I never do it in steps. In business, you just put it in and crunch it and get it out. Never do, because then you're going to approximate, and that's going to give you something that makes you very angry. Okay, I'm going to put this in there, not forgetting my decimal. Open parenthesis, 1 plus decimal 1 divided by 12, close parenthesis, up caret 48. And I should deposit at least $537.14. You would probably do like $550 start, and then you'll be safe. You never put exactly what you need, but the book wants the exact answer. 1-4. Oh, I'm sorry. I can't read. Thank you. I would have got it wrong. It's definitely 1-5. I apologize. Okay. Is everybody comfortable? Okay, we're going to take a short break now, and then we'll start the next one. Everybody get up, move around, ask me anything you want.